Transformer. In our daily life, we use various electrical appliances which require working voltage different from the voltage of the mains. The voltage of the mains is 220 volt, whereas a doorbell needs 6 volt. Television needs several thousand volt. To provide suitable voltage to different appliances, we use transformer with them. So what is a transformer? Transformer is a device by which the magnitude of an alternating EMF can be increased or decreased. And a transformer does not affect the frequency of the alternating voltage, which remains 50 Hz. So the principle of a transformer works on the principle of electromagnetic induction. What is electromagnetic induction? Electromagnetic induction is a phenomenon in which an EMF is induced in the coil if there is a change in the magnetic flux linked with the coil. Transformer makes use of two coils having different number of turns. The two coils are the primary coil and the secondary coil. So the given alternating EMF of which magnitude is to be changed is applied across the primary coil, and the appliance in which output is to be obtained is connected across the secondary coil. When there is a change in the magnetic field due to varying current in the primary coil, the magnetic flux linked with the secondary coil also changes, and so an induced varying current of same frequency but of different magnitude flows in the secondary coil. A transformer cannot be used with a direct current source because if the current in primary coil is constant, then the magnetic field due to primary coil remains constant and there will be no change in the magnetic flux linked with the secondary coil, and hence no EMF will be induced in the secondary coil. A transformer consists of a rectangular soft iron core made up from the thin laminated sheets of soft iron. So one arm of the core, the primary coil P of insulated copper wire, is wound. This coil is connected with the source of alternating EMF. On the other arm of the core, secondary coil S of insulated copper wire is wound. The induced alternating EMF is obtained across the terminals of this coil. The ratio of number of turns Ns in secondary coil to the number of turns Np in primary coil is called the turns ratio. So turns ratio N is equal to number of turns in secondary coil Ns divided by number of turns in primary coil Np. So in this section, we are going to study about two types of transformers. One is the step-up transformer, second one is the step-down transformer. So during the transmission of electricity from power generating station to the consumers. One step-up transformer is being used and 3 step-down transformers are being used. What is the reason these transformers are being used? We'll study in detail. For a transformer, the turns ratio Ns by Np is equal to Es by Ep, where Es is the EMF across the secondary coil and Ep is the EMF across the primary coil. So we have Es by Ep is equal to Ns by Np. That is the turns ratio N. The magnitude of EMF induced in the secondary coil, it depends on 2 factors. Number 1, the ratio of the number of turns in the secondary coil to the number of turns in the primary coil. That is the turns ratio. Number 2, the magnitude of the EMF applied on the primary coil. So the magnitude of EMF depends on these 2 factors. First one is the turns ratio. Second one is the magnitude of the EMF that is applied in the primary coil. In case of an ideal transformer, where there is no energy loss, the output power will be equal to the input power. So power in secondary coil is equal to the power in primary coil. And what is the formula for power? P is equal to voltage into current. So here the voltage or the EMF across the secondary coil is Es and the current across the secondary coil is Is. So the product of Es and Is is equal to Ep into Ip, where Ep is the EMF across the primary coil and Ip is the current across the primary coil. So from this relation, when the EMF is more, the current will be less. This is to balance, this is to maintain the power constant. This is the output power, this is the input power, right? So from this relation, we can write Es by Ep is equal to Ip by Is. We already know Es by Ep is equal to Ns by Np. Therefore, Ip by Is is equal to Es by Ep is equal to Ns by Np. A step-up transformer is used to change a low alternating voltage to a high alternating voltage of same frequency. That is, Es is greater than Ep, where Es is the EMF across the secondary coil and Ep is the EMF across the primary coil. The number of turns in the secondary coil is more than the number of turns in the primary coil. That is, Ns is greater than Np, because of which the turns ratio N is equal to Ns by Np, right? So N will be greater than 1. And what about the current? The current in the primary coil is more than in the secondary coil. So did you notice? Greater the EMF in the secondary coil, less is the current in the secondary coil. This is to maintain the power constant. So the current in primary coil is more than in the secondary coil. Ip is greater than Is. So this is the reason the wire in the primary coil is kept thicker than in the secondary coil. Step-down transformer is used to change a high alternating voltage to a low alternating voltage of same frequency. That is, Es is less than Ep. And the number of turns in the secondary coil are less than the number of turns in the primary coil. So Ns by Np is the turns ratio N, which is less than 1. The current in the secondary coil is more than in the primary coil in case of a step down transformer. So the wire in the secondary coil is kept thicker than in the primary coil. The use of thicker wire in a coil, it reduces its resistance. Why? The thickness is inversely proportional to the resistance. Okay, thicker the wire, less is the resistance. So therefore it reduces the loss of energy as heat in that coil.